Hi everyone. Today what we're going to work on is the nth root, or starting chapter 6, which is all about roots and radicals. So we're going to take a look at some definitions and then simplify some radicals, cube roots and square roots, and with numbers and with variables. All right, so let's take a look at what we have some definitions. So if you remember, this is a radical. This is what we're used to seeing, square roots. So now we're going to have a number in with our radical, and that number is going to be located on that little shelf guy right there. And we're going to use the letter n to represent that. That is the index, which is the degree of the root. It tells us what root we're taking. Now, normally we don't have anything there. That's a square root, but we can have a cube root, a fourth root, fifth root, and that number would be located in that position. Now, this is our symbol, right? So that's not a problem. And then we have the number underneath the radical, which is called the radicand. So for example, we could have the fourth root of 81, where 4 is our index, 81 is our radicand, and then we have our symbol. All right, so our definition is going to go like this. We have a to the n is equal to b, with a and b being real numbers, and n is a positive integer, and a is the nth root of b. So what exactly does that mean? So it says a to the nth equals b, then the nth root of b is equal to a. Or if we put some numbers in there, let's say it's 5 squared equals 25, then the square root of 25 is equal to 5. Okay, so we have two possibilities here, two choices. You can have either an odd index or an even index. So if there's an odd index like cube root, fifth root, seventh root, then there's only one solution and it's going to be written as the nth root of b. But if we have even is a problem because we can have two choices. We can have the number underneath be a positive value. Then there's two solutions. So I've been saying, the square root of 25 is positive 5 and negative 5. That's what we're talking about. If the positive root, then we call it a principal root, which is just the nth root of the number. But if we're talking about the negative root, we're going to have a negative sign out in front, or we would call it the opposite of that root. Now, if the number underneath is a negative number, we don't have a solution. We're only looking for real solutions here, so no i's involved, so no imaginaries. All right, so let's take a look at this. Would we have a real solution here? And the answer to the first one is yes, because we can take the cube root of a negative number. In fact, that answer is going to be negative 3. But over here, we have the fourth root of negative 81. And we can't take the fourth root of a negative number, so this is a no real root. Okay, because we're not going into the imaginaries. So if you take a look at these next two, we have that we're going to square negative 7, we get 49. We can take the square root of 49, so 7. So yes, we have a real solution. And then we can't have a negative number underneath, so we have no real solution for that. All right, so I want to review simplifying radicals. Now, we did this way back in Algebra 1, and if you remember, we made factor trees. So let's take a look at the square root of 45. So if you remember, we did 45, and then we broke it down to any two pairs of factors, and then we kept breaking it down till we get to what we refer to as prime factorization. So since we're looking at square roots, I'm looking for a pair so that I can multiply those together, and they are now a perfect square. And then my other number, this 5 over here, he has no pair, so therefore I'm just going to leave him underneath the square root sign. If there were other numbers that didn't have any pairs, let's say there was like a 2, I would multiply them together and put them underneath the same square root sign. So the square root of 9 is 3, and then we have the square root of 5 as our answer. All right, let's try this one. I don't know if we've done cube roots, but it's the same thought, that we're going to break this 40 down into factors. I chose 4 and 10, but you can pick any two pairs, and find a group of 3 of the same numbers. So I have 3 2's here, and those are all going to get multiplied together. And again, 3 is because I'm looking for a perfect cube. So this is going to be the cube root of 8 and the cube root of 5. So the cube root of 8 is 2, cube roots of 5, and there's our solution. All right, so take a minute, pause the video, and see if you can finish up 2 and 4. All right, so here's the solutions I got for 2 and 4. I got negative 3 cube roots of 3 and 3 square roots of 10. Okay. All right, let's take a look at something a little bit more involved. So here we have variables involved, and that's going to be a little bit different. So when I do these, I break it down into let's do our numbers and then let's do our variables. So first thing we're going to do is let's simplify the numbers. Okay, so simplify the numbers. Okay, so I'm going to just kind of separate it into sections. I'm going to do the cube root of 24. And again, I'm going to break down 24. I'm going to choose 8 and 3. You can choose whatever two numbers you want to. And she is 4 and 2. And then this is 2 and 2. So I want to group my 2's here because they are all the same. And I want 3 because we're doing a cube root. So here they are. So I get the cube root of 8 when I multiply that together, and the cube root of 3. He doesn't have any other pairs. So I get 2 cube roots of 3. Now we're going to put this all back together in a few when we're done, so just kind of leave him hanging out. Then now we're going to simplify our variables. Okay, and this is like the step 3, 4, and part of 5. So I'm going to do them separately. I'm going to do x, y, and z. So if you think about the cube root of x to the 4th, okay, that means I'm looking for a group of 3 x's, because x times x gives me x cubed, and the cube root of that is x. So x to the 4th actually is 4 x's multiplied together by definition. Here's our group of 3, so we're using the same thought process as we would for numbers. So this is going to be the cube root of x cubed, cube root of x. So that becomes x cube root of x. So we get the cube root of x cubed is just x. Then we're going to do the same thing with our y's. The cube root of y to the 6th. So we have 6 y's. Okay, in this case, we have 2 groups of 3. There they are. So we get the cube root of y cubed, and then the cube root of y cubed, which is just y times y, or y squared. Now, while we're working through this, I want you to kind of see if there's an easier way to do this, because I don't want to keep doing this for every single variables that we have. This is a lot of work. Okay, and then z to the 5th. So again, I'm just taking them individually and seeing what we can come up with. So again, this is 5 z's. Okay, so we have the cube root. I look for my group. There they are. So we have the cube root of z cubed. And then we have 2 left over, so the cube root of z squared, which is z cube root of z squared. Now again, see if we can come up with a shorter method, because it's taking forever. All right, and then we're all said and done. We're going to put them all back together. So we're going to simplify our results. So let's say simplify. Okay, so I'm going to put them all together. So all the guys that are outside the radical are all going to get multiplied together. So I have 2x y squared z. Cube root. And then all the guys that are underneath the radicals. So we have a 3x and a z squared. So there's our solution. Now I would hope that you kind of got a shortcut, because this whole process of section 2, 3, and 4, that's going to take a while, especially if you have a lot of variables. So let's see if we can find one. I looked at it and went, well, hey, this is the cube root. And then I have an exponent of 4. And if I look, 3 goes into 4 one time with 1 left over. Let's see if that works. 3 goes into 6 twice. 3 goes into 5 once with 2 left over. I think we found a shortcut. All right, so for variables, what we're finding is that if you take the index and divide it into the exponent, it's going to give you your solution so that you don't have to do this whole writing out thing all the time. So let's work with that and see if that helps us. So let's take a look at this. So we have the square root of 16, which is 4. And remember that the index here is 2 because I'm doing a square root. So 2 goes into 8 4 times. There's your solution. Let's try this one. The square root of 25 is 5. 2 goes into 3 once with an x left over. 2 goes into 4 twice, and there's your solution. Let's try this one. 8, I may have to break that down. Let's take him on the side, break him down. Okay, so we're doing a square root, so there's a pair. So square root of 4, square root of 2. Okay, now remember there's a little 2 here, so I'm going to do my 2 into 4 gives me x squared. 2 into 5 gives me y, because 2 y's, and a y left over. And 2 goes into 3 once with a z left over. So do what we did in the problem. We're going to simplify this down. I'm going to take all the guys that are on the outside of our radicals and put them together. So 2x squared y squared z. And then what's underneath our radical is 2yz. And there's your solution. All right, so pause the video and try doing the next 3 on your own. Okay, so this is what I got for number 4. So there's no numbers, so I'm going to just do 3 goes into 3 one time, x comes out. 3 goes into 4 once with a y left over. And then 3 goes into z, it doesn't, so the z still stays underneath. So over here I did my cube root of 8, so he was a perfect cubed, didn't remember that. So 3 goes into 3 once, we get 1x. 3 goes into 6 twice, so y squared, no leftovers. And 3 goes into 2, well, it doesn't, so he's cube root of z squared. For 6, I did the cube root of 32, so here's my cube root. So I broke him down, I got a group of 3 of 2s, so there's my cube root of 8. And then these 2 that are highlighted in purple, they're going to get multiplied together, and that's where the cube root of 4 came from. All right, so then I did cube root, 3 goes into 1, oh, he doesn't. 3 goes into 1, he doesn't. And 3 goes into 9 3 times with no left over. So our answer is 2 from the 8, the 4 goes underneath. So 2z cubed 4xy. I hope this helped. I hope you have a great day, guys, and I'll be talking to you soon.